Good afternoon, everyone, and welcome back to UK Construction Week Online, and welcome to this our last session for today. And I'm just, for those of you who are joining for the first time, pop your questions in the discussion box, please, and I'll ask those at the end of our session. And also it's a good chance to have a chat with other delegates as well. So this session, I'm delighted to be joined by Professor John French from the Cambridge Innovation Parks. John has become a recognised leader in sustainability and low carbon innovation and holds a chair in enterprise and sustainability at the University of East Anglia. John is also CEO of Adapt Low Carbon Group and is an advisor on a number of universities and financial institutions. And today he's joining us to talk about some of the successes he's had with Cambridge Innovation Parks, and traditionally to look at an area of the sector that perhaps hasn't been known for net zero or sustainable projects. But John can tell us how that's changing and looking at how we can meet the challenge for net zero with commercial and business spaces. So welcome, John. How are you?
Hi there. Afternoon. I'm great, thank you.
Brilliant, good stuff. So I'm going to drop off the camera now and leave this to you.
Thanks very much, Nathan. So nice to meet you all virtually for this quick talk. I'm going to take us through a few past projects that I've done, both at the University of East Anglia and also a project that's live at the moment at Cambridge, and then talk a little bit about some of the work we're doing at the Innovation Park and some of the challenges that we've got facing us around net zero. At CIPL, as we call it, Cambridge Innovation Parks, these are my colleagues, fellow directors Rick Parisi and Stephen Warburton. And as a business park, we are pioneering the transformation to net zero as part of the Cambridge Innovation Park community. Obviously, there's a lot of business parks and science parks in Cambridge. We're keen to lead the way on this. Sustainability, absolutely critical. If you haven't heard of the Sustainable Development Goals, please go and look them up. We call them the SDGs. And they're all relevant, but some of these are particularly important to us, especially number 3, good health and well-being, and number 9, industry, innovation and infrastructure, for example, and 11, sustainable cities and communities. But of course, the one that we're going to focus on in particular today is number 13, which is climate action. Now, this is really important. It's a bit like COVID, really. The COVID crisis is all about bringing down the R value. With climate change, it's all about bringing down the CO2 levels in the atmosphere. And, you know, 2018, we had the report from the UN's climate panel telling us we had 12 years to respond to that, and it's now 2021. So we need to get on with this. And given how long it takes to plan and develop facilities, whether they're industrial facilities or commercial buildings, clearly we need to get a head start on adapting our buildings and building new buildings that meet new standards. So just moving here to some of the key findings, you might think we're making progress against climate change, but actually we're making very poor progress at the moment, with something like a 50% increase in CO2 levels since 1990. And they continue to grow. So without dwelling on this too much, we have to find new technological measures and changes in behavior to limit the increase in global mean temperatures. And that's to 2 degrees. At the moment, we're on track to probably nearer 4 degrees. So it's important that the whole sector comes together, especially in construction, to address this. Now, how do we know the energy performance of our buildings? We can use EPC certificates or other forms of proxy assessment, or we can take aerial photographs and use heat cameras. And so this is an example of a heat camera taken of the University of East Anglia. This is actually a few years ago now, but you can see the heat loss that's coming from these buildings. This is not what you want. You don't want to be really seeing any heat loss from these buildings, because that equates to high levels of energy usage and by default, high levels of carbon dioxide emission in order to power these buildings. So Really, to get to zero carbon, we need to move away from steel and concrete. The built environment is responsible for some 40% of the UK's carbon footprint. We need to start thinking about reducing what we call embodied carbon, and that's the emissions associated with building, extracting, manufacturing, packaging, transporting, and constructing, all aspects of creating and disassembly of buildings. We need to look about getting away from too much steel, perhaps using wood in future, and looking for long life cycles and end-of-life strategies for buildings, which doesn't return carbon dioxide back to the atmosphere. Lots of work is going on around this, and we have the Construction Declares group, which are moving ahead very quickly on this. But we do need to take serious and bold actions to mitigate climate change. Next slide, please. So just talking a little bit about the history and legacy, I'm going to focus on two projects. One is the University of East Anglia's Enterprise Centre. This was probably the first passive house and BREEAM outstanding building in the commercial and university sector when it opened in 2015. But in particular, it focused on local supply chains and the use of natural materials. And then the University of Cambridge, CISL as we call it, the Cambridge Institute for Sustainable Leadership. We are currently doing a deep retrofit of what used to be the telephone exchange in Cambridge. And that project is a live project on site at the moment. We'll talk in a moment about the performance criteria that we've set for both of these projects. Next slide. Now, the Enterprise Centre, to start with, got off to a bit of a slow start. We started planning it in 2008, got the funding in 2011 and went to site and completed it by 2015. And then it started to get recognition because of its green credentials. Here we are seeing the Passive House magazine ask if it's the UK's greenest building, which I think it may still be. But we're always delighted to hear about other or better examples, because the whole point of projects like this is to set the standard for others to work with. Next slide, please. Now, the standards we set for that project are summarised here. The key ones I'm going to just pick out: 100-year life, design life, passive house certification, BREEAM outstanding, very low embodied energy, focus on local supply chains, high use of biorenewable materials, in fact we said 70%, and integrating soft landings and post-occupancy evaluation into the project delivery. Can you move to the next slide, please? Great. Here's a picture of it. Rather beautiful building. And you can see from this that it is pretty much all timber and natural products, except for the lime-rendered lecture theatre in the middle. And on the left-hand side, you can see thatch. It's got a vertical thatch cladding. And on the right-hand side, it's using an exterior MDF board as a fascia panel. So quite nice design, or solar panels on the roof, very contemporary and very much in the spirit of architecture at the University of East Anglia. Now, UEA has been a pretty impressive campus at Norwich because incrementally it has improved its energy performance of its buildings. And here are some data. You can see some different buildings on the campus and how much energy they consume. And you can see there quite how low the energy consumption of the Enterprise Centre is at less than 50 kilowatt hours per square metre per year. And you can also see from the orange bar there the contribution of solar panels to the energy balance. So that's quite an improvement on the most energy consuming building on that graph, which is the Sainsbury's Centre Art Gallery, built in 1978. So lots of coverage, lots of publicity, as you can see from this picture, lots of natural materials, including fabrics and textures that are around the building. So architecturally, the vernacular has moved away from glass and steel and moved towards natural fibres, natural fabrics and timber. Embodied energy. So you can consider embodied energy, embodied carbon in many different ways, but what we're trying to do here is to minimize the amount of carbon we spend on different elements, either the frame or the upper floors or the roofs, and store as much carbon as we can through what we call biogenic storage in the structure itself. And you can see from this graph, the left-hand bar, the tallest bar, is the impact of the concrete foundations on the carbon footprint of the building. Had we not had concrete foundations, we could have brought this carbon footprint down to about 120 kilograms of CO2 per square meter over a 100-year life. Now, interestingly, that's still not zero. So when you hear people talking about zero carbon buildings, you have to think very hard about how are they getting to zero? What is it they're not doing? Or where is it they are storing carbon or offsetting carbon in order to get to zero? Next slide, please. Cambridge University in 2019 announced it would become the first university in the world to adopt what we call a 1.5 degrees science-based target. So what does that mean? That's the 1.5 degrees as stated in the Paris Protocol after the last climate change talks. And science-based means that we are taking an highly analytical and measured approach to the emissions from different types of activity. Furthermore, we said we want to get to 75% decrease by 2015. So this is pretty, so on 2015 by 2030. So this is pretty ambitious in terms of the targets. And this is not atypical. Most institutions now, most science parks that are linked to universities are following this lead and setting very ambitious targets. And that kind of sets the scene for this project. So this is a fairly ordinary building, single layer of brick, built in the 30s, but we have taken this on board as a deep retrofit. So on the basis that it's quite carbon intensive to build new buildings, and we ought to be recycling the building stock that we've got, this project is all about how you can get to the kinds of performance that you've just seen in the Enterprise Centre, but in a more traditional building. We are on project, as I said. We've mapped the different criteria and performance criteria. We're working with the WELL standard, with Enefit, with BREEAM. And we've also said we would like this to be an exemplar of the circular office and also of bio-based material. So pretty challenging. We'll move on to the next slide, and you can see there, for comparison, the performance criteria that we've set for this project. Where does this differ from the Enterprise Centre? Well, we've included in this the WELL standard, because that isn't directly targeting environmental performance specifications. It's targeting health and well-being, and we're looking to create a space that is very good for the user and is good for health and well-being. So that's taken us into new territory. We've also introduced the circular economy, resource utilisation, minimising waste, and maximising upcycling and recycling as a key element of the project. This shows the mapping of criteria. This was developed by our colleagues at BDP. And you can see from this how the WELL standard, the Enefit standard, the BREEAM standard maps onto these other criteria. So there's a helpful level of overlap. The passive house standard, which is really driving us down to very, very low levels of energy consumption, only maps really onto air quality, thermal comfort, and the commissioning of the building. So it's quite narrow in its focus, but it is really, really helpful in driving down energy use. Okay, next slide, please. We're looking at embodied carbon at the moment. So this is not the final data. We will be publishing through CISL data on embodied carbon for this project, but it's quite challenging because most of the embodied carbon tools that you can use on buildings don't really take account of the embodied carbon in the historic structure that you're conserving. So we're looking at that at the moment to see how we can compute that into the data for the whole project. So at the moment we are carbon positive. We're sitting at around, collectively around 700 kilograms of CO2 per square meter over 100 years. We're trying to get that down to about 300. What's the effect in terms of the appearance? Well, this building is in a conservation area in the city of Cambridge. So the only fundamental change that you'll notice from the outside is the fact that the windows, which were traditionally a sash window with rather ineffective secondary glazing, have become quite advanced triple glazed windows. We've removed any obstacles to the light transmission, and we've modelled the effect of those windows on the light levels, but we've also modelled the effect on reduced energy consumption, again, by transmitting more light into the building. So it will give it a contemporary look. This was highly contentious because the planning approval process had to be prepared to take on board this level of change in a conservation area. So that was something we had to argue for at committee, but we did eventually get this through. So again, a helpful precedent, I think, in terms of adapting old buildings into a new climate context. Energy consumption cost. Why would you do this? Why would you? Obviously, your conscience drives you to address low carbon, but we're all businesses, and this has got to make sense. And if you're going to invest upfront in a deep retrofit, then it has to be possible to get some payback. So we've done some modelling on this, but if we just look at the top graph here, you can see the existing building is the red lines, standard fit out, Part L, that's the orange, and then the proposed scheme which we've got, which we're now delivering, looks at your energy costs here over 15 years. So we've saved over £1 million based on current energy cost and energy value. We've saved over £1 million in energy costs by investing in these upgrades. At Cambridge Innovation Parks, where I'm Director of Sustainability, we have taken this whole approach to a campus level. So we're now saying, let's not just look at buildings in isolation, let's look at a whole campus. And we're currently in planning at the moment to have this scheme go to committee in June. This is interesting because we've got historic buildings, we've got a large former MOD building in the centre, we've got buildings at either side of it that are new timber frame structures. And we are progressively increasing the quality and performance of these buildings in terms of not only their carbon footprint, but reducing their energy consumption and addressing the usability through the use of timber-based materials. And we've gone with a sawn timber approach on this. So we've moved away from glulam on the grounds of cost, and we're looking at affordability as a key indicator for delivering this scheme. So CIP's journey to zero carbon is looking at not only a master plan, but also incremental improvements in buildings, natural ventilation, use of air source heat pumps, large windows for natural light, modular construction. We're looking at what you would recognise as off-site construction, manufacture, modern methods of manufacture, and bringing it to site for erection. Significant use of renewables and EV charging points. But the key difference really here is the complete lack of wet trades and the move to modularity and off-site construction. CIP is developing several sites. We've got, as well as the north site at Waterbeach, we are currently developing our full business case for West. So this is a site, as you come into Cambridge on the west side, we're looking to have a whole campus approach on an 11.5 acre site as you going past Hardwick on the way into Cambridge. This is particularly interesting because here we're saying, let's look at buildings that provide for businesses that are in the science park and low carbon community, that are exemplary in themselves as companies, as tenants, but let's build exemplary low carbon buildings, minimize the carbon footprint of those buildings, and have an integrated campus approach that copes with all aspects of energy and renewables, which takes us right through to sustainable travel planning as part of that. We've appointed architects on this, and we're making good progress on this scheme at the moment. Got lots of ideas. We're interested in things like plants and biophilic. having a biophilic core, the health and well-being concept. And we're looking at essentially a green network, the integration of the wider plant-based environment on the site with the buildings and the users. We better speed up a little bit, I think, Nathan. And here are some ideas we've got around aspects of different parts of the ecology being integrated into the whole scheme. Here's our timeline. So as I said, I started with those slides at the beginning looking at energy and carbon and climate change. We are planning to get to 75% carbon reduction by 2030. And we have plotted this out in terms of our developments, both on north and on west. This is quite challenging because we've got to both simultaneously build new buildings to new standards, but we've also got to go back and retrofit the old ones to meet those standards as well. So the learning from projects like the university's One Regent Street project is absolutely critical going forwards, because retrofit is not quite as easy as it looks. It's harder, in fact, than new build. Lots of different standards out there you can go with. So if you are thinking of doing this yourself, take some advice around which of these standards to operate against. As I say, I'm most familiar with using BREEAM, but there are others that you can use. And I quite like the One Planet framework. And I think some of these other concepts like the Living Building Challenge are definitely worth investigating and looking into. We have a big debate running at the moment as to the merits of refurbishing versus demolition. And these slides, which will be available to you, show how we are currently trying to understand the carbon footprint associated with retaining buildings as opposed to basically knocking them down and building new ones which are better performing. So I think the jury is out in terms of which is the best way to go on this at the moment. Obviously, if you can recycle and reuse, it's better. But as I said, it's harder and it has more technical challenges associated with it. Embodied carbon, just a note, there are lots of different standards out there. We use a tool called Ecolab, but you should be aware of the fact that there are several different standards. CIBC has just published its TM65 Embodied Carbon in Building Services. You've also got advice coming from the structural engineers, and there's also the new London guide called LETI. It's worth pausing and reviewing all the different approaches to embodied carbon that exist, and perhaps taking advice on which way to go in terms of which way of measuring and reporting embodied carbon, because it's not a level playing field at the moment, which makes it very hard for developers, quite frankly, because you need to know where you want to be on that. The Oxford-Cambridge arc, I think we're going to see a lot of developments in the sustainability space as this area opens up and as we see this huge level of growth that is expected between Oxford and Cambridge. And I see our project on West Cambridge as being one of the first of many on the Oxford arc. So basically, it's not too late. You might think it feels a bit like it's getting a bit hot around here with climate change, but the reality is that you can start planning in significant change. And I'm currently looking at projects around more basic buildings, industrial warehouses, commercial units, to see if I can come up with a toolkit for relatively easy retrofit of some more traditional buildings that are widely available on industrial estates and industrial units, because we clearly need to address that area urgently as well. Thank you very much.
Brilliant, thank you very much, John, and that was great, and thank you for whistling through that. I know, time is quite short, but yeah, we've got one question in which was from Gordon. He's asked, did you have the embodied carbon figures worked out pre and post construction?
Embodied carbon?
The figures.
Yes, we did. In the case of the UEA project, we modelled it first. We used initially the Timber Research and Development Association software, TRADA, and then we used Ecolab as a predictive tool. And then my team at UEA analysed all the real data empirically, the old-fashioned way, and measured it up and compared it with the estimates, and it came out pretty much the same. So, but that's quite a labour-intensive way of doing it.
Mm-hmm.
And I suppose the point I would make is you need to be very, very critical of what you are using by way of data, what the software is using by way of input data to allow you to get an embodied carbon assessment. And you need to think about not just what's going in during the construction period, but what you are spending in terms of refurbishments at stages during the building's life, changing the carpets, changing the floors, resurfacing programs at 30-year intervals, and then end of life. Think about, if you're constructing a new building, what's the end of life? If you take it down and all the timber gets burnt, you've returned all that CO2 back to the atmosphere. So ideally, you want end of life where you're reusing it into other forms of construction, recycling or furniture or other end of use purposes. Now, it's hard for the next generation in 100 years to be able to take what we've created now and do that, but we have to think in those terms for sustainability.
Okay, good stuff. And you mentioned the new campus plans, and there'll be a lot of timber used in that particular construction project. What I mean, are you looking for the timber industry to get involved with the any innovation that you're doing? Are you looking for new innovations from timber companies?
Yes, we've run a timber challenge last year. We've got a number of companies that we're working with now on a framework to help us do this. But essentially, we've got two things that we want to achieve with timber. Firstly, comparable price to building and steel. Now, that's always been quite hard, but it's getting easier because steel prices have gone up since Brexit. So that's kind of narrowing the gap. But obviously, we want intermediate technologies. We don't want the most Rolls-Royce approach to timber framing. And then the other thing is we'd like is local supply. We don't really want the extra embodied carbon associated with imported timber if it's come halfway around the world. We would rather use local timber and local supply chains and create local jobs. But that's quite a big shift for us, for our economy. The British economy tends to import quite a lot of timber historically. In fact, we're one of the biggest timber importers historically.
Okay, and then I guess the learnings from this. How widely will you share? It seems to be a sort of an open source system here where you're sharing learning. So, is that your intention with the new projects, and how can the industry learn from Cambridge Innovation Parks?
Yes, I mean there's two ways really. One is we are quite open about what we're doing. We've had a number of articles in the press about what we're doing. We will continue to do that. But we can also provide specialist advice as well if people want it on a consultancy basis around individual projects, if that's helpful. And we're accumulating a range of case studies of projects, not just our own, but others in Britain and others globally, where we can actually point to projects that people have done and how they've got on in terms of not only the approach to project management, but also the achievements they've managed in terms of zero carbon.
Brilliant. Okay, thank you very much. Well, I think that brings us up to the half hour. So thank you very much, John. You mentioned the slides would be available. Should they visit your website for that, or should we ask people to get in touch with you directly?
People can get in touch directly. That's fine.
Okay, brilliant. We'll put that out on the group. But brilliant. Thank you very much. And hopefully we will look forward to seeing you at our next event, which hopefully will be in October, when we can meet in person and we'll talk some more. But brilliant. Thank you, John.
Thanks ever so much, Nathan. That was very enjoyable. Thank you.
Cheers. Bye-bye.
Bye, everybody.